Okay, so yesterday we looked at adding mixed numbers by changing them into improper fractions. Today we're going to look at subtracting mixed numbers by changing them into improper fractions, and it's literally the same exact thing. So if you felt good about yesterday, you're going to feel good about today. If you're still a little lost, this will give you some extra practice. It's really the same thing except you're finding the difference instead of adding. So we're going to do subtracting, and then I'm just going to do my quotes because it's going to be the same thing, okay? Page 74. All right. Okay, let's write our objective. Today I will subtract mixed numbers, okay, using improper fractions. So let's say that you have 2 2/3 subtracted by 1 1/3. My steps are exactly the same as yesterday, except now I am subtracting versus adding, okay? So the first thing we do is what? What do we have to do to this? Convert, right? We need to convert into improper fractions. And what do we call this method? Good, the Dorito method. Yum. Okay, so step 1, convert. So 3 times 2 is 6. 6 plus 2 is 8. Your denominator stays the same. So our first improper fraction is 8/3. Okay. Next, 3 times 1 is 3. Plus 1 is 4. Your denominator stays the same. So now I have 4/3. Okay. Step 2. Subtract numerator. Does your denominator stay the same? Yes. Denominator stays same. Okay? So let's do that. Step 2, subtract the numerator. So we can do 8 minus 4/3 because they have the same denominator. That gives us 4/3. Step 3 is convert to a mixed number. So now I have 4/3. I can convert it by drawing an area model. So I need one whole broken into how many parts? 3. Okay, and then I'm going to shade. So I have 1, 2, 3. Did I shade 4? No, I only shaded 3. So what do I have to do? I have to draw another one. 1, 2. So I have 1, 2, 3. I only need one more. So this shows me that I have how many holes? I have one hole, right? Because 3/3 gives me one hole. And then I have 3 parts with only one shaded. So my new number is 1 1/3. So when I subtract 2 2/3 from 1 1/3, I get 1 1/3. Okay, let's prove it. So prove with number line. So let's draw this big number line. Got a 0 and a 1. How many spots do we need? Okay, so I'm going to draw my number line. I wrote the 1, but I crossed it out because I'm not actually sure. I think we might go past 1. So I have my 0. First thing I need to do is draw up to 8/3. So I need to do 1, 2, 3, 4, 5, 6, 7. So I have 1/3, 2/3, 3/3. Oh, here's my 1. 4/3, 5/3, 6/3. Oop, there's my 2. 7/3, 8/3. Okay. So first thing I need to do is shade all of my 8/3. And then I need to cross out how many? 4, right? So I gotta cross out 1, 2, 3, 4, and that puts me at 4/3, which we know is 1 1/3. Okay, let's prove with an area model. Okay. First thing I do is draw my 8/3. So 1, 1, 2, 3. I gotta keep going. 3, 4, 5, 6. 7, 8. Okay, so that's 8/3. I need to subtract how many? 4. So 1, 2, 3, 4, and that gives me what? 1, 2, 3. There's my whole. And my 1/4, which is the same thing as 4/3. So I proved my answer with a number line and with an area model. Okay, I want us to look at this number line really quickly. So I want us to look where we can find the 1 and the 2 and how we know that that's true. So we know that this is where the 1 is because 3/3, remember that fraction bar is a division sign, so 3 divided by 3 is 1. Now how we can find 2 is we know that 6 divided by 3 is 2. So that's how we knew to put the 2 there, because 6 divided by 3 is 2. So if we kept going and we did 9/3, let's say we extended our number line, what's 9 divided by 3? 3, right? So our whole number of 3 would be here. Does that make sense? Okay. Let's do 3 2/3 subtracted by 1 1/3, and then let's prove with a number line.